This is video 3.3.1, and the goal of this video is to be able to expand and condense logarithmic expressions using properties. So we're going to learn a few properties, and then we're going to practice expanding and condensing logarithms using them. A lot of common mistakes come up in this section, so be paying close attention in class and throughout this video to the rules that do work, and we'll talk about the rules that don't work when you get to class. First of all, the properties that you'll want to write down and put in your notes. These are three properties of logarithms that are very simple, and they're called the product rule. The product rule states that if you have inside of a logarithm any base b, you have a product m times n, we can rewrite the product as a sum of the two logarithms. So log base b of m plus log base b of n. So the product turns into a sum of logarithms. The quotient rule is the second rule, and it's very similar to the product rule, but of course it's a little different. This rule states that if you have a logarithm with a quotient inside, a division problem, m divided by n, you can separate that into a subtraction problem, log base b of m minus log base b of n. The final rule is called the power rule, and the power rule is like it sounds. There's a power on the inside of the logarithm. So this is a n to the n to the y inside of the logarithm. We can rewrite this by simply dropping the power out in front and doing y times log base b of n. These three rules are going to allow us to manipulate logarithms, simplify logarithms, and solve logarithms in the long run. And these three rules follow directly from the rules you learned about exponents in past years. We'll look at how these rules came about when we look in class at some examples of exponential rules that you know, and we'll relate them to these rules. But pay close attention to how we'll use these rules to expand and condense in this video. First, we're going to look at examples of expanding. So these examples, our goal is to expand the expression, which means we're going to make it bigger and add more logarithms by separating things out using the rules. So first we have log of 10 of x. Well, 10x means 10 times x, so we'll simply use the product rule and separate it into a sum. We've expanded the expression, but we're going to go a step further and try to simplify whenever we can, because we know log of 10 is 1, because log is in base 10, and 10 to the first power equals 10. Question 2 is a little bit more complicated. It's natural log, but what's good is the natural log, again, follows the same rules as the log, except for the base is now e. We're going to start by using the product rule again, the quotient rule. We're going to start with the quotient rule and separating this into a subtraction problem. E to the third minus natural log of e to the third minus natural log of 7. Then, after using the quotient rule, we'll move on to go a step further with the first part and use the power rule to drop the 3 in front. We've fully expanded at this point because inside the natural logarithms there's just a single number, but I can actually go a little bit further and simplify further by changing the natural log of e to 1, because the natural log of e is 1. And I've got a simplified expression that's been expanded. 3 minus natural log of 7 is the most expanded simplified form. So question 3. Now we're in base 7, 5 to the 4th. This one's going to be quite simple. We're simply going to use the power form. That's as expanded as I get because, again, I have a single number on the inside of the logarithm. Question 4, natural log of the cubic root of x. So what we want to remember is that really this means x is to the 1/3 power. So just like you've been doing in class, you need to rewrite things as powers when you see a square root. Now we'll use the power rule by dropping the 1/3 in front and rewriting it as 1/3 natural log of x. So these 4 examples are very simple examples of expanding the expression, but you're going to look at some more complex ones in the second part of this video here. These complicated examples require multiple uses of the rules, and there is an order that has to be followed. So if you look at log base b of x squared square root of y, you see a power, x squared. There's a product, x squared times the square root of y, and then of course square root of y is also a power. But what's really important is that you have to do the power rule after you separate things, because you can't do the power rule unless everything inside is raised to the same power. And since inside, I can't drop the 2 out in front because the square root of y is not to the second power. And I can't drop the square root of the square root power, which is 1/2, out in front either for the same reason. So what we're going to do first is do the product rule, and then we'll worry about dropping the powers. We'll use the product rule and separate this into a sum, and then we'll use the power rule on each case, and we'll separate and pull out the number out in front on each case. So there is an order to follow, and when we're expanding, the power rule will come only when everything inside is raised to the same power. This is done. I've fully expanded this expression. Question 2 has a similar case. Now we have a quotient. We see powers on the inside. The cubic root is a power. Y to the 4th is a power. But we also have a quotient. So we separate this first by using the quotient rule. And we'll separate this as log base 6 cubic root of 3x minus log base 6 36y to the 4th. But again, the first expression can actually be finished by just doing the power rule and taking the 1/3 out. But the second part, I actually want to use the product rule to separate it. And what's really key here is that both of these terms have to be subtracted. They have to be subtracted because the original log base 6 of 36y to the 4th, that was being subtracted. So everything that it splits up into needs to be subtracted. It's kind of like we're distributing the subtraction to each of those pieces. So now we'll rewrite the first piece because it's finished. But the second piece can be simplified because 6 to the second power is 36. So log base 6 of 36 is 2. And then last but not least, I'll use the power rule on my final piece and drop the 4 out in front. This is the most expanded form of this original logarithm for number 2. So the key things you should have seen from this slide was that you have to separate things with the product and quotient rule before you can use the power rule. Now when we start to go the other direction, so when we start to see now examples of condensing logarithmic expressions, this is when we're taking multiple logarithms and trying to put them into one logarithm. We're going to go opposite direction of the order that you just did. But let's look at a simple example first to understand what it is we're supposed to do. In this first example, we have log base 4 of two quantities that are being added. So we're going to use the product rule to put them together as a product. And of course, we're going to simplify. And log base 4 of 64, we actually know the answer is 3, because 4 to the 3rd power is 64. Question number 2. Also rather simple. It starts with a subtraction problem. Again, we have log, and we have 2 logs, both in base 10, and it's a subtraction problem. So because it's subtraction, I'm going to use the quotient rule and rewrite it as a 4x minus 3 over x inside the logarithm. That's condensed because it has a single logarithm. Part 3 now, question 3, has multiple steps. Before I can condense the logarithms, I actually need to get the 1/2 and the 4 out of there. So this is where we're going to go backwards in our order that we were doing with expanding. We're going to start with the power rule, bring the powers in. Then, after we bring the powers in, we're going to use the product rule and rewrite this as a product. And of course, square root of x is the same as x to the 1/2. So we'll use square root of x for ease of use. And now that is completely condensed. Everything's inside of one logarithm. Example 4 is very similar. We have a couple of things going on. We have 2 things being subtracted, and we have multiple logarithms. We also have a coefficient, the 4 in front of the first logarithm, the 2 in front of the second, and the 1/2 in front of the third. So let's start first by using the power rule and bringing in the powers on all 3 of these. The next thing that we'll use is we're going to use a simple case of the distributive property. We're going to distribute, and actually not distribute, I should say factoring. We're going to factor out the negative from both of these because that whole quantity is being subtracted. And that's important because now I'm going to go back one more step and use the quotient rule. After I've done the distributive property, the quotient rule will state that x to the 4th is on top and everything in that subtraction is on bottom. So I kind of use 2 properties here. I use the quotient property, the quotient rule, excuse me, to create x to the 4th over that second piece that was in the parentheses. I also use the product rule in the denominator, and I put the two pieces together, b squared and the square root of y together because of the product rule. Now I fully condensed because I have one logarithm in my result. So this video was meant to just introduce you to some of those rules. You'll be practicing them plenty in class, so be prepared to do that. Here are your two questions, your multiple choice question and your free response question. Your goal is to start by expanding the expression that you see here and figuring out which answer is equivalent after you've expanded. Your free response question is actually going to ask the opposite. Your goal is to condense. Now when you explain your answers, just try to explain what properties, what rules you used, and maybe in what order. That way I can see if you're doing the right order and if you understand how to condense and expand. Bring those questions into class and be prepared to work hard. See you tomorrow.